And
Oh,
I'm going to
we're
push
live.
out the live now. Tweet. Tweet. Tweet, tweet. Oh, I had that one ready to go. Notifications are blowing up because Callie and Matthew Trask are having a conversation and getting PHP Roundtable's Twitter handle up in this conversation. So I'm getting notifications left and right. Callie's watching on the big screen. Wow, that's nice. Callie's from Internals. He's one of the release managers for PHP 7. And yes, watching on the big screen. Hi, Callie. We're live now. I should probably be looking at what we're doing here. Okay. Welcome. This is PHP Roundtable. This is a podcast of developers discussing topics that PHP nerds care about. I'm Sammy K. Powers, your host, and today we are looking at a very special thing. PHP is known for running really bad code really well, but it has a dirty little secret. Deep within its code is a hidden stack bomb. You can cause PHP to completely crash with just a few lines of code, and today we're discussing why this happens and what we want to do, or what we can do maybe, to fix the issue. And as always, you can chime in live if you're listening live on Twitter. Notifications already kind of blown up with Callie and Matthew Trask. By the way, Callie assigned me a bug and said, welcome. Somebody's having something's going on with the C-Spring in PHP 7 on a certain platform. He's like, here's a bug for you to fix. And he assigned it to me. And then Akita Pavlov's like, I'm a bit skeptical here. I have to dive into this, see if there's actually anything that I can actually do with this. There's probably nothing I can do, but I'm very honored that you assigned me this bug. Thanks, Callie. So today we are talking about this dirty little secret. And in order to do that, we have a special guest. And it's typically on the PHP Roundtable, we have several guests. But on episode 64, that was PHP 7 source code, a deep dive, where we had Sara Golemon from Internals take us deep into the PHP source code. And once again, we have Je suis YOLO, Sara Golemon.
YOLO. I decided French was over. It's German now.
Oh yeah, ich bin YOLO. Sie ist YOLO. So me and Sara have been, she's been helping me learn PHP internals very well. She's been an excellent mentor in trying to figure out what's going on. And as I sit there like a dog saying, I don't know what's going on. We make these epic elephant videos together whenever we get the opportunity at events. And I think we're the only ones who find them both funny and interesting. So
probably true.
Maybe one day we'll get it to where it's interesting for everybody except for just us. So I'm a little, I guess I should have like a deep dives with Sara collection on the PHP Roundtable if we keep this up. It'll be like you just go with all the Sara videos. Hi, Sara.
Hi. You let me talk finally. That's nice.
Yeah, I know. I'm sitting here talking. Oh, I'm sure. I'm actually really nervous because you told me that you're ready to grill me on some stuff on what I think is happening behind the scenes. So let's see what happens because yeah, I don't know what's going on. So I guess we could start off before we get into this dirty little secret, the Segfault stack bomb is what we're calling it. I think that's your term, Sara. That's how you say stack bomb. Okay. So TLDR for PHP devs who aren't used to having to deal with memory allocation. Can you give us a TLDR on memory allocation? Because I think it's really important for this talk.
Well, okay. So, I mean, I wasn't where I was expecting us to start, but sure, why not? Memory in PHP is kind of a soft and fuzzy thing, especially as you jump between the 5 and 7 barrier, because our memory allocator changed significantly at that point as well to adopt some of the practices you see in TC-malloc and JE-malloc and things like that. Anyone who's ever tried to sort of gauge what their script is doing has probably run memget usage or memory get usage, whatever the command is, to sort of see, well, after I've started playing with these structures, I was using this much, and after I was using, oh my gosh, this much more, and but I've unset my variables, so there must be a leak somewhere. And we get those reports from time to time from people kind of fundamentally not understanding how memory usage works in PHP. I don't think I'm going to go deeply into it, but it is going to be sort of an important topic in what we're talking about here, because PHP does its best to minimize the amount of memory that you're using at any given point, and that means a lot of shared references between variables. And I don't mean PHP level references, but I mean like under the hood. If you've got two strings with the word hello world in it, they're probably actually pointing at the same address, even if they're not quote unquote references of each other. And that's great for reducing the amount of memory usage and actually improving your performance because you're not duplicating things all over the place. But it also adds some complexity to the system. But I don't think we should jump straight into that yet.
Where do you think we should jump in?
So I think let's start with actually the genesis of how you got on this topic, because you were working on a video for PHP Test Fest, right?
Yes. Yeah.
So maybe you can talk about what you observed.
Yeah, good call. Let's start where this all started. So I was looking for lines of code to cover for the Chicago PHP user group, and I was going on the gcov website, gcov.php.net, and looking for red lines that could possibly be covered by a test for PHP source. And as I was finding this red line under the JSON extension, there was one for JSON serialize, which is the interface that you add to any object, and you basically you can have a method called, I think it's JSON serialize. It's a method that returns something that you want JSON encode to basically return as the serialized string, serialized JSON string. And I was trying to hit this like error case where JSON serialize would return some sort of error, or that method return an error, or throw an exception in some sort of place. And while I was trying to do that, I hit a segmentation fault, which is never supposed to happen in PHP. There should always be like a nice error saying, oh, we've run out of memory or something like that. It shouldn't just go segmentation fault. And that's where I ran into this bug, and I tried to patch it, and I actually posted a screencast online of my process of going from finding the bug to patching it at sammyk.me. And so I got this video, and then Sarah watched it, and she's like, oh, you could do it better this way and this way. And then there was a bunch of people else who chimed in from internals who were like, hey, this is a much bigger issue. You found the dirty little secret PHP stack bomb.
Yeah, that's a pretty good summary of it. And yes, it is sort of I wouldn't call it a dirty little secret, because we have discussed it on the list publicly a few times. And it's a known issue with the way PHP deals with certain conditions. And in order to sort of talk about the root cause of that, because you found one particular case, you were constantly creating a new object from the JSON serialize method. And that object was the object that you were about to serialize. So, of course, it has a JSON serialize method, so it should call that, which should call that, which should call that. And so you're constantly creating this more and more and more objects. You keep calling that a stack bomb. It's actually not a stack bomb. You're running out of memory is what's happening. And the way that PHP deals with those fatal errors when you run out of memory or when you cause any kind of fatal error is actually at the fundamental lowest layer of that. So before I describe what that is, I'd like to ask you, how do you think PHP deals with fatal errors?
Okay, in terms of memory allocation?
Well, any kind of fatal error, like whether you have tried to call a function that doesn't exist, or you've run out of memory, or you throw an uncaught exception, or anything that causes an E error. How do you think PHP deals with that?
Oh, this is good. Okay, well, I'm guessing there's two main separation points. One is at the parser level, right? If you just have invalid syntax, you're going to get a fatal that happens before you even hit any of the runtime, right? Like it's just right at the parser level. So
that is a fatal error, actually, yes, but it's an eparse error. So technically, it's not the kind of error I was asking about.
Okay.
Because that one is actually not handled in the same way as runtime fatal errors.
Gotcha. Okay. So if we're talking about runtime errors, I have a feeling that it has something to do with fancy memory management and allocation stuff that goes on behind the scenes. I had asked you ahead of time. I was like, here's some show notes of where I think we should send this conversation, but I don't know what I'm talking about. So I'm really going to rely on you to actually make sense of this. And one of those things that I had put in there was like the heap versus the stack and like what that means and all that kind of stuff. And you had mentioned something about like, well, PHP is interesting because most of the stuff is happening in the heap. So I don't know. I think it might have something to do with that, but with PHP, so far, all I've run into with these error things is like more of like a Segfaulty type of response. But I'm not really sure how PHP handles.
Okay, fair enough. That's fine. I just wanted to make sure we didn't have any preconceptions that we're going to start from. So
maybe one thing.
Okay.
Does it have anything to do with any setting for memory limit?
Well, that will lead into causing a fatal error. Like when you go past that INI setting for memory limit, that will actually trigger it as a fatal error
Gotcha.
within the request. So it goes into the request fatal error handler, just as if you had called a non-existent function or something like that.
Right.
But let's talk about a little bit about how the PHP virtual machine works. PHP parses your script into bytecodes, as we've talked about before, and it steps through those bytecodes at runtime one at a time. And the way it actually sort of processes the activity through your script is, let's say you hit an instruction to call a function. You're going to call, your own like hello_world function. So it creates a new stack frame. Now this is a PHP script stack frame. So this is actually an allocation on the heap, which is sort of the big global address memory space. And it says, all right, we are currently calling this function. Here's the handler for this function. Here's the parameters as we're passed to it. Here's our parent scope, which is maybe the main function or some of this, whatever function we were in, we called it. And it creates that little linked list of stack frames. These stacks within the scope of a VM are all heap allocated stacks. They are just regular like malloc chunks of memory that describe the state of the virtual machine. These are distinct from the stack that you might have learned about in a comp sci class, where you've got this contiguous block of memory that is just being pushed downward as like registers are being pushed onto the stack or instruction pointers are being pushed on. That's a C-level stack, or I mean, it's a native stack is what it really is. That is a completely separate beast. And those kind of stack bombs are the ones that tend to result in a whole lot of buffer overrun kind of exploits where you can execute arbitrary code. Fortunately, that's not what we're talking about here. We're talking about a virtual machine stack, which again is just a block of memory on the heap. And the specific class of segfaults that we're running into are very largely double freeze. So we're not even looking at the contents of that memory for the most part, except to just say like, verify that this is a valid memory block and that its size is meaningful. We're just doing verification looks. We're not actually saying, hey, give me a stack pointer and a code segment instruction pointer pair, and I'm going to go run off and do that. And they're not actually pairs anymore because this isn't real mode, but never mind. So the segfaults that we see are just some very passive reads, and the CPU says, hey, you don't own that memory right now, so I'm just going to wash my hands of you and let you die. So the good news is these are by and large not security concern segfaults. I'm going to say by and large because I can't guarantee that, because anytime you say something absolute about security, you're probably wrong, and I don't want Scott to be on my ass about that, or
Scott Arsuzuki.
Yes, on my tail about that. Keep this podcast clean. We'll just beep that out later.
Yes.
And I'm also going to say that. What was I going to say about that? That they're not generally not security concerns. And the other thing I want to say about this is that if you're on a shared hosting environment, it is actually possible to use some of these techniques to crash PHP to piss off your shared hoster. Please don't piss off your shared hoster. Like, that's not a nice thing to do. They won't like it, and you'll get kicked off. And since PHP is generally run in a multi-process environment rather than a multi-threaded environment, you're probably not going to piss them off enough to actually harm other users meaningfully anyway. So all that out of the way, this is all. This is why this class of Segfault is, part of the reason why this class of Segfault is persisting through PHP versions, because it's not this critical, urgent thing to fix. It's a, man, this really sucks and we don't like it and we don't want to talk about it too much, but because the solution to it is actually very hard, we're going to think very carefully about how we fix it. So let's talk about what's actually happening. What's actually happening comes from, again, how we're dealing with these fatal error conditions. And did I finish talking about the VM? Sorry, I didn't finish talking about the VM. Backing up off the stack a bit, speaking of my own Stack Overflow. As you're executing code, you're running through these bytecodes and you're saying, okay, do this add operation, this assign operation, whatever. Oh, here's a function call. We need to create another virtual machine stack frame to put on top of that. Oh, we're going to call another one. Let's put another frame on top of that. And so as you call functions recursively, you are building these stacks of frames higher and higher and higher and higher. And eventually you are going to run out of memory to allocate to put these frames on. So you will get a fatal error at some point doing that. The way PHP sort of tries to unwind itself when one of these fatal errors occurs is at the beginning of a request, it says, all right, CPU, here's my recovery point. Take a snapshot of all your registers, where you are on the stack, all of these sort of low-level things, and just kind of put it aside over in this bit of memory over here. This is my recovery point. When a fatal error occurs, and that might be out of memory, or it might be somebody calls exit is technically a fatal error, or what do we say, calling undefined functions. It goes and says, all right, restore me back to that condition right there when everything was wonderful and beautiful and halcyon. So it restores all of the CPU state, but all the memory is still exactly as it was a second ago at the end of your request. So the PHP code then says, all right, I hit some sort of abnormal exit, whether that was someone explicitly calling exit or they had a fatal error, whatever happened, something other than reaching the end of the natural script and just gently gliding out into nothingness happened. So I want to start to unwind all of my state. Well, I know I've got all these variables in the global symbol table. I know I've got all these stack frame pointers. Okay, let's start unwinding the stack frames backwards. Get rid of the local symbol scope. I'll allow all these things to destruct nicely, wind it all the way back to root, make sure the global symbols table gets freed up, references go away, and try to clean up after myself gently. This is the right way to do it, because if you just sort of throw away all of the memory that you have previously allocated, sure, your memory's free, but what about different like socket resources or maybe other sort of persistent information that can live from one request to another isn't necessarily getting cleaned up. If we free our variables, their destructors are going to be called and we'll actually free those resources. So it tries to do the right thing with it. Now, imagine what happens if that fatal error occurs right in the middle of a critical path of execution. Like, let's say we are making a copy of a variable because we're about to do a copy and write change to it. All right, so we say, all right, let's increase the reference count to this variable by 1 because we're now holding it somewhere else during this copy operation. Let's allocate a new block of memory. And oh, we ran out of memory. Crap. All right, bail out. Well, we now have an extra reference in that variable that doesn't actually belong to anyone. That's weird. Okay, what happens when we start cleaning up after stuff? Okay, we're decrefing all of our variables down, down, down. We wind up with one variable left over that has a reference that nobody actually owns anymore. Well, that's actually fine. At that point, we can throw away the data. And the absolute worst case is there's some resource out there that's, you know, not being taken care of. Fine, it's whatever. Let's say we're doing a different kind of operation where we need to separate two variables. Sorry, separate two references to a single variable. So we've already got two things that own this variable. Maybe we decrement that reference first, and we set the second variable to a fresh new allocation of memory. There you go. Oh wait, that allocation failed in the middle of that malloc call. So the variable itself still points to that same underlying data structure, but it's a data structure that only has one reference associated with it. Now, as we start unwinding things, we decref we detour the first reference. It goes to 0, gets rid of the underlying resource. We detour the second reference. It tries to decrement a reference, a piece of memory that doesn't exist anymore. That is a segmentation fault.
Right.
So it's this process of trying to do this rational cleanup on memory that isn't necessarily in a rational state. Now, why doesn't this happen in other programs? Well,
dynamic data structures is my guess.
No. So every program is going to have a slightly different way of dealing with this. But generally, when you're dealing with more managed languages, they're going to basically prevent you from shooting yourself in the foot. But PHP is written in C89. C89 doesn't have exceptions. It doesn't have destructors. It doesn't have any of the sort of self-cleaning artifices that you find in other languages like, let's say, C++. If PHP were written in C++, then we would hit a fatal error, and we would actually treat that as an exception. The exception would go backward through the stack on its own and unwind things nice and cleanly. If you look at HHVM, for example, which is C++ based, when it does these reference deletions, it will actually go ahead and do that decrement, try to do the alloc, and when that alloc fails, the destructor part of that actually restores it back to its original state that it was in before taking the other variables out of reference. I'm oversimplifying that massively, but the point is C++ is designed to deal with these sort of long jump throws that come out of execution back to some arbitrary earlier state because it has exceptions. C doesn't have that. So what we do is we fake it. We use that set long jump thing right at the beginning, and we just call long jump to go all the way back to the beginning, and then we manually unwind the things that would have been unwound by the exceptions. So
is that slow?
What's that?
Is that slow?
It's not fast, but I'm going to say it's no slower than if the script had set a flag to say start dying and had just returned from the function and continually returned backwards. Like PHP is all the time is cleaning up after itself. Anytime you leave a function, it's unsetting all of the variables in that function so they can destroy properly. It's deleting that execution frame. It's doing all this work in the normal execution anyway. The only time that's going to be a super long time to happen is when you're doing some kind of infinite recursion where you've gone out 20,000 calls to the same function before you hit your memory limit. It's going to have to undo all 20,000 of those. That's going to be slower, but I mean, you've done something stupid there, so.
Right, or you can just segfault it and not worry about it, right?
Well, if the process segfaults, then yeah, that's a lot simpler.
It's faster.
Yeah, segfaults super fast. If we shard to def null, then it will be even faster.
Yeah, I'd heard, I guess, I don't know, in C++ that you're not supposed to throw exceptions because of that stack unwinding is supposed to be really slow, right? Like, is that the general? That
I think no, that's a bad piece of advice in my opinion, and this is subjective and this is personal opinion. The advice against exceptions sort of comes from the idea that an exception is going to take longer to deal with your stuff than manually dealing with yourself, which is true, but only nominally so. And frankly, the amount of things for you to get wrong is high enough that your developer efficiency and your code safety is, in my opinion, totally worth throwing exceptions. That's what exceptions are designed to do. And if they're too slow, then the correct solution is get on GCC and Clang developers to make them faster.
Right.
So
I guess PHP handles exception quite differently, right? Because we've been talking about specifically error kind of things, right? And during the runtime, as opposed to maybe in userland throwing an exception, because there is no stack unwinding necessarily with that, right? I mean, I guess you eventually have to if you're shutting everything down, but at that point, it's more like there's the way that PHP handles exceptions. I know Nikita Pavlov has a blog on this, and it goes into crazy detail, but it's kind of scary the way that, like, it just seems like there's like global state of like exceptions and levels of like, this is like 3 levels deep, and they're just like, I don't know. I've tried to wrap my head around it, but like the way PHP handles exceptions is quite different, right?
Well, so yeah, the way PHP handles exceptions is not the way C++ handles exceptions. So I'll say that for a start. The way PHP handles exception is basically what I described a few minutes ago about ways that you can exit from your code. When you throw an exception in PHP, what the engine does is it says, I'm currently handling an exception. Here's my exception object in this global variable. Well, global to the scope, to the request. And then it does a go-to basically to the end of the function and lets it return. So the function actually does return in that case. And that allows PHP to do its normal cleanup of unset all the variables, yada, 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 yada. When that function exits, that gets up to the next scope, and the return from the function call, before it actually takes that return value and puts it wherever it's going to do something with it, it checks, hey, is an exception currently being thrown? If so, jump to the end of the function and return, which again goes through all of the unset all the variables, clean up after ourselves in that function call, and that continues on and on and on until we find a function that actually has a catch block in it. Once we find a function that actually has a catch block in it, says, oh, there's an exception being thrown, but here's a catch that we're inside of. So we're going to go to that catch point. We're going to set the variable to our exception object, and then we're going to clear our global exception variable. And then execution just continues from there. You could emulate this in PHP script if you wanted to, and heck, maybe I'll write something up just so people can visualize it. But yeah, these are a much simpler form of exception that fits PHP actually quite well.
Gotcha. So kind of backing up to maybe re-summarize like all that stuff that you said. There was a lot, so I'm not going to do good at re-summarizing this, but just looking at PHP's runtime, everything's happening in the heap, where you would typically not have things happening, right? Like, isn't this stack like a little bit faster in memory allocation than the heap?
So yeah, the native stack. The way you allocate memory on the native stack, well, actually, let me say, the way you keep track of the native stack is that you have a stack segment pointer that says, here's where my stack starts. Here's the whole stack. And then you have a pointer within that stack that says, here's the top of that stack, or actually the bottom, because it's usually allocated downwards. When you need more memory, you just say, move that pointer forward, down, whatever direction is appropriate. And now that whole chunk of memory is what you're going to use. This is completely contiguous because as we, well, the only place you should be allocating space on the stack is in a function preamble. You say, okay, I need space for my parameters coming in, or I need space for my local variables. So when you leave a function, all you do is you just move that stack pointer back as you clean up the variables. So it's always contiguous, mirroring the progress of your function execution. But that's native stacks. PHP stack, again, is actually more of an execution scope than a stack. So it is a pointer to a hash table. This is just a regular PHP array. So the $x variable is the X key in that PHP array, and it's got a value. Again, I'm oversimplifying. There are ways that we make this actually run much faster. And this can be arbitrarily sized and moved around. I don't know how deep I want to go here. Yes, it's allocated on the heap because as PHP is doing its execution, the execution within its native scope is, generally speaking, not going super deep. We're not recursing, through our local execution loop deeper and deeper and deeper. Like if you call hello world 1, which then calls hello world 2, which then calls hello world 3, that's not 3 calls deep in CLand. That's 1 call deep in CLand to create our PHP frame, and then we come back. And then we do another call to create our hello world 2 frame, and then we come back. So we stay at a fairly low number of stack levels within C, unless there's calls back and forth between C and PHP. That can actually build up our stacks, but we're not going to get into those. God, where was I? Oh, yeah. So
getting deeper in the stack.
we keep PHP's virtual machine stack in the heap because it allows us to manage it independent of the native stack. Is sort of the bottom line for that. Again, HHVM actually does this a little bit differently. HHVM will actually use the native stack for its execution well, I won't say rather than using a local stack, because it also uses a local stack for the VM portions of it. HHVM is a little weird because it's partially JITted, partially virtual machine.
And it looks like HHVM actually has a solution to this particular problem that we're talking about too, right? Like I ran it on eval and it didn't seem like HHVM was having so many Segfaulty problems. At least it returns some sort of error.
Yeah, so again, because HHVM deals with its fatal error conditions using actual C++ exceptions, it is able to unwind things correctly. And it doesn't have to worry about being in a weird, inconsistent state when that log jump happens. So gotcha. HHVM is not susceptible to at least a large number of PHP's hidden segfaults.
So it sounds like the real key to this is understanding how PHP allocates memory in a context like you were talking about earlier, where you have a string that you copy and then maybe modify one of the strings, right? Like, is that kind of the quintessential like dynamic data structure memory allocation issue that's the problem?
At the root of it, all of these, including the example you found with JSON serialize, all really come down to dealing with exceptional circumstances and specifically fatal errors. And memory allocation is one very easy way to make that happen. It is possible to do that outside of the scope of memory allocation, I think, but I wouldn't be able to come up with a repro of that very quickly. Whereas I sent you a one-liner that can crash any version of PHP, which I don't want you publishing because I don't want people trivially crashing PHP. That would make me sad. But yeah.
So how do we, so like, what would you say is like the most fundamental way of kind of thinking about this problem to kind of like go on to that next step of like trying to solve it?
Well, so Stas, on one of these reports, I think it might have been on your pull request, in fact, gosh, I just had it here. He sort of set down 3 sort of fundamental rules for how we fix this problem. Number 1, we don't want to hit false positives because that is actually worse. We don't want to be breaking in conditions that are currently working. Number 2, we don't want to slow down the execution, which is a reasonable thing. We want PHP to run fast and efficiently. And honestly, if these segfaults are only happening in sort of carefully tailored situations that people aren't trying to do, then we shouldn't slow down all execution just to fix that necessarily. And 3, that it needs to be capable of dealing with arbitrary stack sizes rather than just setting some arbitrary limit, like, oh, you can't go past 100 stack depth. Well, that will probably solve it, but it'll also artificially limit situations that can deal with 1,000 call stack limits. So that's not an optimal solution either. Your solution was to say, as long as you're returning an object of a different class, it's fine, which I think several of us replied isn't going to work if you've got class A and B are both JSON serializable and they return new instances of each other. Like that'll immediately not work. So we definitely need a more general solution than that.
Absolutely.
Sorry, go on.
Do you think that there is a general solution to this, or do you think each use case has to be addressed independently?
So I actually offered off list a solution to what I reckon is about a 70% a coverage of the problem. So it doesn't cover all use cases, but it does introduce slowdowns. So that is something that we're continuing to see if we can find better ways to present that same solution or a solution that'll hit all use cases, or at least if we're not going to hit all use cases, at least not slow things down. Like we can maybe bend on one of those things. Like we can maybe take a little bit of a slowdown if it actually does properly hit those other 2 goals. But if we're not even hitting 2 of those goals, then we kind of need to come back to the drawing board.
Right.
Do I think it's tractable? I do think it's tractable. It's just very, very hard. It's one of those problems that, if you go to a CS professor, they're also going to be going like, I'm not sure how you're going to do that. We have it doesn't help that we have some particular limitations on the kind of tooling that we can use. Like we want to stick with code that can be compiled and run just about anywhere, right? We want PHP to run on Plan 9 or whatever OS you happen to be on. So that means keeping the dialect mostly to C89, maybe some C99. The Intel extension's got a little bit of C++, I think 03, but Intel is optional, so it doesn't matter as much. The core stuff really needs to be run anywhere. So that puts a constraint on us, but I don't think the solutions are unsolvable. They're just hard.
Do you think that the solutions will inevitably have trade-offs that will negatively affect PHP going forward?
If I were to, so this is not a final answer on this, but if I were to place a bet on it, I would say that when we find a solution that doesn't hit false positives, that does cover every edge case, that actually solves everything, it's probably going to have a small but measurable performance impact. Being careful does that.
Right.
And when we get that solution, we're going to have a kind come to Jesus moment about it and figure out if that's what we want to do. And it probably will be. But I don't know.
Is there any, you said you proposed a specific solution out there. Is there any like solutions out there that are seriously being considered, or is it just kind of still being?
I would say it's largely a backburnering process right now. We're all thinking about this problem. Stas is thinking about this problem. Nikita's thinking about this problem. I'm thinking about this problem. A lot of people are thinking about this problem because we don't like that PHP can be made to Segfault. It feels bad.
True.
And you should be working on this problem as well.
Yeah, well, I'm. It's at least good enough to try to educate myself a little bit more about the internals structure and everything, and having these conversations to help me really. I'm, at the moment, I don't feel like there's much I can particularly offer other than like, hey, it's broken over here. What should we do about it? And then you're like, oh yeah, we've known about that for 10 years.
What you can do is you can have conversations. I did show you that really easy repro case. And yes. We can, in a less public forum, I can go in and show you some of the really dirty bits of where to be looking for this stuff. And I mean, honestly, anyone who's listening, you probably know where to look already, including the bad people. So yeah, it's out there.
Only good people listen. Only good people listen to the PHP Roundtable. There's no bad ones.
That's right. Well, the PHP Roundtable people are the best people.
They are. So in the issue that I had submitted, the bug fix that was not even a bug fix at all, but Nikita Pavlov pointed to the bigger issue and said that we should look into something called stack guard pages, which now that I've talked with you about this a little bit, I'm kind of curious how this would even work, because it seems like since PHP doesn't use like the native stack, it's using kind of the pseudo heap, the pseudo stack in the heap. I'm not really sure how. Well, first of all, can you tell us what stack guard pages is and like how like a TLDR on that, and why it might not be a good solution, or why it is a good solution? Not why it's not a good solution. Obviously, like Nikita Pavlov is a genius, and whatever he says is probably right. But
so I'm going to preface.
I put you in Nikita.
I'm going to preface my response to this by saying I don't know what he's on about, because as I said, PHP's actual VM stack is a completely separate bit of thing. So. Yeah, stack guard pages, as you say, they're designed to sort of mitigate this problem of your stack growing out of control by creating sort of a neutral zone where if you go too far, you're still going to hit that page fault because you've mem-advised that bit of page as unwritable or unreadable or whatever. So you're going to get a fault that will crash you, or at least be trappable is more ideal, as we could trap a page fault in this particular region so we can exit cleanly. Without actually overwriting bits of real data or allowing bits of real data to override our stack and send us off to different instruction pointers somewhere. This is something specifically about native programs. If PHP had a JIT, and as actually I understand it, some people are working on that, so that may become an issue at some point, this would be a thing. I'm not sure how he imagines it applying to PHP's VM. I would love to hear him talk more about that, and I wish he could have been on this podcast too.
Yeah, me too.
Because I don't think I've ever actually spoken to Nikita out loud, come to think of it.
It was awesome. He was on a PHP Roundtable not too long ago, and everybody was like, he's a real person? I thought he was a robot.
He's not a script. Oh my gosh. Yeah.
I definitely would love to try to get him to come back on again. But yeah, it's an interesting proposition to do stack guard pages when it seems like everything's happening in the heap. So stack guard pages basically is like you have like this layer between the stack and the heap, and if you end up going into the stack guard pages zone, it's like, oh, you're not allowed to access anything past this.
Basically, yeah. It's like a honeypot for native code. Yeah, is the simplest way I could describe it.
And we don't really have to worry about that, right? Because we're not in the native stack anyway, and plus we don't have to worry about these like the stack clash, I think is what it's called, the thing that's like the thing you can exploit by doing stack overflows and all that stuff to run arbitrary code. Or
it is a thing that we have to worry about while we're writing the VM, but it's not it's a very separate thing from the actual execution of PHP scripts. So I'm not sure exactly what he's going for there, unless he knows about some new bit of the PHP 7 runtime that I don't, which is entirely possible.
Well, okay, so I do have a question to clarify something in my head. Is this problem related to to recursive data structures, or trying to clean up basically a dangling pointer that kind of got halfway screwed up while trying to allocate memory?
It's the latter. The fact that you hit it through recursion is secondary, honestly. What you really hit was a memory overrun when you tried to instantiate a new object. That requires allocating memory. And that memory allocation block puts you just over the line and also happened to have left you in an invalid state. I think. I haven't dug all the way into your Segfault, but that's my instinct says that's probably what happened.
Gotcha.
The fact that you got there by recursion is just the vehicle you took to reach your memory limit. I think, maybe.
So we've had a little bit of chiming in from Twitter. Callie he says he's fairly enjoying Sarah. Oh, Sarah M. Who's that? Sarah Miles. That's I don't know who that is. I guess he meant Sarah MG hand illustrations on PHP Roundtable. I guess you've got some good ways of describing.
I think he's talking about this.
Oh yeah.
My sort of Italian way of speaking.
Heather makes fun of me when I'm doing PHP Roundtable because I go really big and I'm like so she makes fun of me like that. Wes Netmo on Twitter. I suggest a fix for the Segfault PHP Roundtable. Thank you for playing with PHP. He's got a screenshot. I didn't even read this before I started talking about it. So thank you for playing Wing Commander. I don't get this. Sorry. I probably should have read this before I was talking about it. It's a. Do you know what he's talking about with the Wing Commander on a PC? We're getting an exception in our memory from EM.
Oh yeah. Apparently he was no. So apparently he was getting an exception in his program that he couldn't track down. So rather than have it output this messed up message, he just had it basically made the message something that looked less troublesome.
Yeah, okay, I do remember that. Yeah, instead of having segmentation fault, it just says, thank you for playing Wing Commander every time it exits on a Segfault or something like that. We won't
necessarily stop failing. We'll just redefine failure to success.
That's such a good idea, Wes. All right, we should.
I'm not sure if that's what he meant, but that's how I read that.
I would love to. I mean, so how realistic do you think it would be for these specific cases to have a thank you for playing PHP instead of a segmentation fault until we figure out what the actual error is?
So I will say it is possible to trap segmentation faults within C code. That is something that can be done. But if you're writing a Segfault trap, then you're probably doing something that you shouldn't be doing.
But why?
Possible, yes. A good idea, probably not.
True.
Mostly because we have no idea what the state of the world is once we are in a Segfault condition. And trying to do anything beyond the most basic is a bad idea. Now, if we only did that on CLI, we could probably make it do something reasonable. Doing it within a SAPI, be it FCGI, FPM, or Apache or whatever, that gets into weirder states because in order to even talk to these guys, you often need to allocate structures. And trying to do a malloc during a Segfault handler, don't do that. You might be able to get a dealloc out of it, which is your stack allocation. But
gotcha.
Trying to be cute would not necessarily help, is what I'll say. Especially since we want people to send us Segfaults.
Yes.
There is this specific class of Segfaults that we're aware of and we want to do something about. But there are probably a lot of Segfaults that we're not aware of that we definitely want to get the reports for. So if you get a Segfault, please open a bug report, give us back traces, instructions on bugs.phpnet on how to give back traces. With the debug build if possible, but sometimes they just don't reproduce. So that's my PSA.
Well, so speaking on that, what if you're submitting a bug and you've got enable debug enabled? What specifically should you submit in the bug report if you're getting a Segfault?
Well, always a reproduce case. If you can get the script down to the minimum number of lines to actually produce that bug, whatever it happens to be, that's great. An example of what you expected the output to be, what you actually got, and if what you got was a Segfault, literally just the word, segmentation fault is a good start. If it is a Segfault, then a backtrace is very helpful. And again, you can go to bugs.php.net and there'll be instructions on how to make backtraces. Definitely easier to do on Linux than on Windows, sorry. Yeah, I mean, if you give us really those things, we can usually figure it out from there. Like a small repro case is gold. The one you gave with your JSON serializable was a nice tiny repro case. Like we could run that on any of our machines and be like, yeah, I got a Segfault too. What do you know?
Right.
That's how you get a bug fixed fast.
Right, with the very small snippets of code that you can reproduce very easily.
Yeah.
Yeah.
Otherwise, you're going to get works on my machine. Try the latest snapshot.
Right.
and a small reproduce does not involve download Symfony 4 and get this chunk of seed data from over here. And no, that's not a small reproduce. I love Symfony, but I'm not going to install it just to fix a bug.
So I guess calling this backing up to the bug that we've been talking about, I guess calling this the stack bomb is a little misleading, right? Because it really doesn't have anything to do with necessarily the stack. It has more to do with, as we said, like kind of deallocating memory or whatever.
Yeah, it's not what I would call it. So
what would be the fancy, pretty name that we would assign to this that CNN would take and run with?
Fatal handler fatality.
Fatal handler fatality. Cool. That's
PHP's fatal handler fatality.
Yeah, I like
it.
That's all I got. Yeah. Well, sort of to wrap up, I kind of want to take two quick tangents, if that's okay with you.
Sure.
One is because we kind of talking in the context of recursion and data structures, which doesn't actually have anything to do with the actual bug itself, which we found out. I was thinking about recursion and how it works, and I know there's this kind of thing you can do, trampolining, where you like basically wrap and tail call recursion when the last thing that you do in recursion is to recur. In those situations, when it's the last line in the function, you can wrap it in a closure and kind of flatten the stack, if you will, I guess, so you don't have to go so deep. I've seen that there is a trampoline what do you call it? Opcode in PHP specifically for, I think it's __ call or something like that. One of the magic methods has this sort of trampolining optimization put in. Is there any way, do you think, when we're talking about dynamic recursive data structures in PHP and the way that PHP allocates memory for it, could there be any optimizations done from this sort of trampolining way or methodology or wrapping tail call recursion?
Trampolining is more about ways that we can take we can make regular user code less expensive, but still allow it to look like it's being as expensive as it used to be. And sort of these call methods are one example of that. If you use call user function, technically you're calling a function that then calls another function, and we want it to continue to look like calling a function that calls another function, or not look like it. I think is one way or the other. But if we have enough knowledge about what function you're calling and how you're calling it, well, we should actually just reduce that to a single function call and get rid of that entire frame in the middle. That would be great. So we have some trampolines to deal with that sort of thing. The tail recursion, I think, is a little bit more broadly applicable because, as you say, if you've got something that's deliberately recursive, like rather than allocate another stack frame and another stack frame and another stack frame continuously, what if you just kept reusing the same stack frame? And when you go to do that recursion, you clear off the bits of the stack frame that are no longer relevant so that you're kind of in an initial state, and you pretend like you came directly into that call, and then you come out. This is a really common optimization that's used in a lot of languages. The difficulty in it is doing it in such a way that still looks the same to the outside user. And because PHP has these objects that can have their own destructor methods on it, there are ways to take advantage of those. There are ways to take advantage of those destructors in a way to cause your program execution to not go the way you expected it to. Nikita actually gave some examples of that in one of his most recent talks, where he had $x = 1, $y equals new some object, unset y, var dump x. And what's the output? Well, you would think it should be. You would think
Just
it should be int1, right? Because you never touched the x variable. Well, in his example, the output was 5 or 2 or something else, because y's the object that y instantiated had a destructor which went out and touched globals sub x and changed it to 5. So PHP can have these weird, spooky action at a distance things happen where it doesn't look like you're actually executing a function, but you really are, because this destructor gets implicitly called when the variable goes out of scope.
Right.
So you've got some variables in scope in your function. They actually have to be destructed properly before you enter that tail recursion, but not the ones that are actually following into that tail recursion. Like if you're passing $y, then $y shouldn't be destructed. It should actually go into the next iteration of the call.
Right.
So it gets a little bit more complicated to implement that correctly. And anytime we're talking about optimizations, you definitely want that optimization to not break things. There was actually, what was it? There was a bug in one of the early 7.2 releases where you could say $x equals NaN, so not a number, like just a literal constant for not a number. And then you could say vardump nan versus vardump $x. One of those would output not a number. The other would output 0. Or no, it might have been, it was comparisons. That's what it was. Vardump nan less than 0 is false, because any comparison to nan should be false. But vardump x less than 0, where the value of x is nan, was true. Or vice versa. I can't remember which way it was. But one of those was backwards because of an over-aggressive optimization. In the compiler, we say, hey, if these are two constants and we're comparing two constants, let's just do that right up front. But that optimization use right up front was forgetting about the special exception for not a number. So the answer was coming out backwards.
Oh.
Somebody caught that, fortunately, because yay testers. I love people who test.
Yay.
They caught that early on, and we got it all fixed up. So no problem.
Very cool. Well, speaking of PHP 7.2, you are one of the release managers for PHP 7.2. You and Remy Cullett. How are things going?
I think
release
it's candidate
4, right?
French, isn't it?
Cullett? Oh, sorry. I don't know.
I don't know. I've never actually heard him say it out loud, but I don't think there's a hard sound on that. 7.2 is coming along pretty good. The major activity on 7.2 has stopped. I think the last sort of like significant push on it was largely to do with Sodium, because that's a brand new extension. And so there were a lot of updates and last minute fixes to make. But things have slowed down in terms of actual development. We're just doing bug fixes now. RC4 came out last week, and it was a pretty solid bug fixes only release. I think Rasmus had one diff that he asked very politely if he could put in, which did add a tiny bit of new functionality to like a debug only path to output another couple of characters in the output of it. So we're like, yeah, okay, it's debug only, and it's just for this one case, and fuck it, you're Rasmus. So pardon my French. Heck, you're Rasmus, so whatever.
The sweaty ice cube terminology, right? Like at this
sweaty ice cube, yes. We're in dry ice territory now. We are, if anything's coming off that ice cube, it's ablating straight to carbon dioxide. So we're in it.
So what you're saying is Rasmus is carbon dioxide at this point.
I have no idea what this metaphor means anymore.
I don't. Especially if you haven't seen the previous episode where we talk about feature freezing and sweaty ice cubes and slushies and stuff. This probably isn't making any sense at all. But
yeah, in jokes. Come on, man. In jokes,
I know.
You
can't do that.
What are you doing?
Do that. So anyway, one last quick tangent before we kind of wrap up officially. I've kind of wanted to make another RFC. I've got one out there for like a trailing comma for functions, which you had the original RFC for that, and unfortunately, like whenever I think you had it for function calls and function declarations as well. The original
I
RFC
had it pretty broadly, yeah. And I should give credit where due. Paul Tarjan. This was one of the first changes he made to HHVM. So we were trying to bring that particular syntax feature back, because actually I found myself liking it quite a lot very quickly. I mean, it treats function calls and declarations the same as arrays. You can have a trailing comma at the end, no big deal.
Yes, and I love that. And I tried to push it through for 7.2, and I had, unfortunately, I had a, well, I mean, fortunately, I went through all the list syntax in PHP and found all the trailing possible commas that we could trail and put them all in their own vote. But I mistakenly, oversightingly put function declarations and function calls in the same vote. So it was just like they had to accept both or none. And so I had
in my opinion, they should be consistent, but sure.
Yeah. And I had a lot of people come up to me afterwards and were like, hey, I would have totally said yes if it were for just the calls and not the declaration. So we have a new RFC out there for just calls, and I think it's going to go to vote this Saturday. So I'm really excited to see how that ends up going. I think there's just enough people who want it that will actually, we might see it in PHP 7.3. I don't know.
Well, I'll say I do tend to want to use it more on the calls than on the declaration. So, okay.
Well, and the beautiful thing is it's really kind of like a 1 or 2 line change in the parser. And the funny thing is, you know, all you have to add is this possible comma group in there, and then it suddenly starts working. But the very first function I tried it on was unset, and I was like, oh, it's not working. My patch isn't working. And then I realized that unset is not a function like you think it is. It's actually a language construct like isset. I was like,
there's a specific separate rule for unset.
I know. I saw that. I was like, crap, I got to change it there. And I think isset, I think, was another one. And so I actually, and so I ended up changing it in a few different places. So it's more than just 1 line, but it's still really, really small patch to sans the test. It's like 3 lines of code change. It's just
well, because you don't actually have to do anything with the comma. You're like, oh, all right, there was a comma there. All right, whatever. Yeah. Fine.
Exactly. And then so the one RFC I just want to really quickly mention, I'm thinking about stealing an idea from other languages where you can have separators and int literals. So like basically like putting underscores in places instead of commas, or if you have a social security number and you're having an int literal, I don't know how you would do that, like, but having being able to do like your 3 numbers, then the underscore, 2 numbers, underscore, and then a few more numbers, and then having that just be just a literal int literal. And I was trying to add that to the parser and was having a little bit of trouble like messing with YY text or whatever it is. I don't know. But then I started thinking, well, crap, what about like if an int literal has these underscores in it and it's a string, like how's that handled? And like it started getting pretty hairy.
Well, I think underscores, you might actually get away with underscores because there's not a way to, like, 1_1 is not going to be interpreted in any other way. And you can separate from a label because labels can't start with numbers. But to me, like the most useful places for these literals would be places where you have like a comma or a dash or a parenthesis. And those all have significant meaning though. Like 123-45-6789, that's a math expression. It's not a social security number.
Right, exactly.
So, yeah, I'd have to see more of that RFC, but like,
well, it's not really an RFC at the moment. I've just been working on implementation, and it's I'm not doing too good.
Whatever happened to retrivables, man?
It's still there. It's at this point it's less implementation and more coming up with more convincing arguments in the RFC, because right now I haven't been able to touch it, but I've got a lot of feedback from a lot of different people saying, hey, it would be a better argument if you could say this and this and this, and I'm like, oh yeah, that'd be better. Yeah, lots of stuff to put in the language.
Yes, I need to take another crack at partial function application. I definitely see this as my path to victory for pipe expressions. But
the pipe angle bracket syntax.
Yes.
Is that what you're talking about?
Well, not angle bracket, but yes.
What is it? Pipe and what?
I'm suddenly forgetting that. Yeah, maybe, I guess it is pipe. Is it pipe angle bracket? Fuck, I can't even remember what the expression is. Jesus, I keep swearing so much.
It's okay. I'll edit it out in post.
It'll just be like beep, 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 beep.
I could just mark it as explicit. It's like if you are Sturgeon, I'll just be like, oh, I'll just mark it as explicit. It'll be good.
You're who?
Or Phil Sturgeon.
Oh, yeah. Oh, great. You're comparing me to Phil Sturgeon. Thanks.
No.
Love you, Phil.
True. Well, oh wow, we've talked for a long time, but we got to wrap this thing up.
Oh yeah, we have. We're at an hour.
Yeah. Do you have any final thoughts on this whole shindig?
So the final thoughts I want to give here are a few things. Number one, don't panic. These hidden segfaults have been in the language for quite some time. They are not as dangerous as they sound. I know the word segfault is very scary, but they're not that dangerous. Particularly if you're running your own instance of PHP, or if you're in a type of shared hosting environment where you have an instance dedicated to yourself, like Platform SH or I think Heroku does it as well. A few of them do, where you have your own instance. You have to go out of your way to misbehave to cause one of these segfaults in the first place. And I'm mostly certain that they're not such that you can force very bad things to happen. Like, remote code executions, that's the word I was looking for. I'm mostly certain that they're not in that category. So don't panic is the one thing I would say. And the other is, bug reports, please. As 7.2 RM, I've got 2 RCs left to go unless we find something major. So the more bug reports you feed into the system, the more we can close up and the more awesome the 7.2 release will be. I'm hearing words that it's as much as 10% faster than 7.1. I don't know how much I trust that, but that sounds pretty awesome. So good work, everybody who's been working on the optimizer. That's where a lot of those gains have been coming from. Yeah, that's it. We're going to have 7.2 out next month if all goes well.
Yay.
Exciting.
November 30th, right?
That is the date, yes.
All right.
I'm pretty sure. I should probably know that date off the top of my head. Yes, November 30th is our scheduled general release.
Oh, yes. I'll be very excited for that day. We'll have to celebrate somehow. Yes. I do want to give a great shout out to Christopher Thomas for the second time has contributed show notes on the official show note repo. If you go to github.com/PHP Roundtable, you'll see a repo there called show-notes. And Christopher Thomas has created show notes for episode 62, which was all things Laravel. So thank you so much, Christopher Thomas, for those show notes in. I really appreciate that. Typically, we have a developer shout out, which is a little segment that recognizes a developer for being awesome in the community, and we recognize them with a $50 Amazon gift card. I don't have a sponsor for this episode. It's not because I don't have any. I have a couple that I just haven't gotten back to, and I'm really, it's my fault. I've been kind of busy on some other stuff, so I apologize for that. And we might not even have one for the next episode. It's just lots of stuff on the plate. But for the developer shout out, if you have gotten a developer shout out in the past 4 or 5 episodes, you should be getting them hopefully today. I got them in the mail, and it takes me a while to actually send you the email with the developer shout out. But hang on, they're coming. Actually, is there any shameless plugs that you want to promote, Sarah, to wrap this thing up?
Shameless plugs. No shameless plugs that I can think of. So I'm instead going to just give a shout out to some of the upcoming conferences that I think are pretty awesome. Yes. PHP Benelux coming up in Brussels in February. Sunshine PHP down in Miami, really awesome conference down there. I'll be at SymphonyCon Cluj in Romania next month. That'll be pretty awesome. Company I work for, Mongo, is holding Mongo World EU in London early November. Hit me up if you need a discount code for that. I'll hook you up. Actually, I think you can just use it. It's Sara Golemon 20 if you want that. So all one word, lowercase, Sara Golemon 20. Mongo World Europe. What else we got?
ZenCon next week.
Oh yeah, ZenCon next week. Yeah, sorry, I'm not going to ZenCon this year because I'm just trying to balance my time. And apparently I'm on the East Coast now instead of the West Coast. But ZenCon, always fun, always really informative. And they have this cool new denim elephant that I want to get my hands on. Yay. So go check that out for sure.
I'll see if I can grab one for you while I'm there, because that's, I know last year, Adam Culp had started handing out extra ones for people I could ship to and stuff. Yeah. I still haven't sent.
Pretty good about that.
Joe. Yeah, I'll try to grab one for you. So I'll add you to the list of people.
Well, we need to make our next video, right? I mean,
Yeah, exactly.
You need to make a video while you're there. Elephants in Vegas too.
It won't be the same without you, though.
I know.
But you could make it your own independent video, and we'll splice them together.
Yeah, I was gonna say, if you send me some raw footage, I'll make some here, and we can do a whole story about elephants. I don't know. They meet up in New York City, and then they fly to Las Vegas or something.
Yes, maybe they could be on Hangouts at one point or something.
Something. Oh, there you go. Yeah, we'll do the whole like watching the live stream thing. There you go. We should be having this conversation offline. This is.
I know, right? We're giving all the secrets away, all the spoilers.
How the sausage is made.
How the sausage is made, exactly. If you have something you'd like to share about the PHP Roundtable or on the PHP Roundtable, some kind of topic that PHP nerds care about, hit me up on Twitter. I'm Sammy K, or just ping the PHP Roundtable. And a couple of cool episodes are coming up coming down the pipe here. Let's see here. We got all things WordPress might be next. It's funny how I've gone this long without having like a WordPress episode, so I'm really excited about that. We still have concurrency generators and coroutines on the list. It keeps getting pushed back, but we're gonna have it one day. We're gonna be talking about PHP 7.2 being released. We'll eventually get to the Fig PHP Fig 3.0. I have two new ones that I kind of added relatively recently: persistence, database, and state. And it's going to be more philosophical about application state, which would be kind of interesting. And the latest one I added was investing in startups as a developer, because there's lots of ways you can invest into startups as a developer without just throwing in some cash. So it should be interesting to talk with some startup investors on that one. I think that's it. Sara Golemon, thank you so much for joining this episode and bestowing your knowledge. That's the way you say it, right?
I think that works Englishly.
Yes, I think I could do that. I'm a linguist. I can make up words. That's how I say it.
That's right.
Thanks for joining us.
This is English. You can make up any word you want.
Exactly. Thanks so much for joining us, and we'll see you in the next episode.
Bye.
Bye.